Okay, what about now? Okay, what about now? What about now? Okay. But I kind of hear it like dimly, but okay. If it comes back, tell me. I don't know why, but it happens. I don't know. Okay. So long parameter list. Let's get right to it. 3 parameters or more is a smell. It came back. Oh, come on. Came back. Oh, come on. Came back. Oh, come on. What about now? Now it's okay. So if I put it on table for some reason, it picks something up from PC, I guess. I'll need to test it. Okay. I'll hold my mic. Anyways, long parameter list. 3 or more parameters means that we probably can group them together. We can encapsulate into an object, and like this, it will be cleaner, easier to read them. Sometimes when those, let's say 5 parameters or more are unrelated, we cannot group them anymore, but we can split a function into a bit smaller function, which takes, let's say, just 2 parameters. So we would split it into 3 functions if there are 5 parameters, 2 and 2 and 1, and we would introduce a side step to make it more clear, because probably many parameters also implies that function does more than one thing, because rarely we need 5 parameters to do something with them. It might not be the case. For example, in some physics formula or some maths formula, we might really need those 5 things that we're passing. So in cases like that, it's okay. But just as a definition of a code smell implies, that it implies that there might be something wrong, but it can be okay as well. Tolerable Streamer said that actions can have 16 parameters. Yes, and I don't know why. I don't know why they made it like this. I don't think it's a good idea to have this many parameters, because it's unmaintainable. But I think in cases like high performance, where splitting something would mean tiny extra processing power is needed, a bit more memory in the stack, well then you might want to use those. But this is a really special case, and in normal cases you wouldn't need to use those. Let's continue. Large class. What a terrible blob we see in this picture, and what a terrible blob a class can become. This code smell is also known as God class or blob anti-pattern. Basically a class which does everything, or simply a class which does too many things. It doesn't have to be a lot. But in this smell, it implies that a class is bigger than 200 lines of code, and that it has many fields and methods. So such class is a smell. If you see such class, the treatment is simple. You just split it into more classes. You should look what a class does and extract it based on responsibility. If, let's say, we have a file class, well, we would think that we need some mechanism to read and write a file, but reading and writing are big things by itself. Let's say reading would be 200 lines and writing would be 200 lines. So instead we should put those in their own classes, so that the file class itself gets functionality of reading and writing from the outside. And like that, we have split the big class into 2 parts, making each part smaller. Another way, when behavior changes, we shouldn't stack behavior in the same class if it's fundamentally different. If we need both things, for example, if in one case we use, let's say, 3 methods of a class, and in another case we use 5 methods of a class, but that other case is, well, it's different, quite different, maybe not really related to the 3 other methods that we initially used, then subclassing might be a good idea of splitting a class, extracting it and making it more maintainable like that. Data clumps is another smell, and it's very similar to long parameter list code smell. It means that there are many properties which are repeating themselves, a group of properties to be exact. For example, we have properties like name, surname, age, phone number, height, weight, and we repeat them 5 times, let's say, across our program. Or we have a person, basically a person, and then, sorry, not a person, but male, female classes, teacher class, and all of them have the same properties, like I said, age, height, name, surname. So instead of repeating those, we could either inherit a parent class and call it person, or have a container for those parameters, for those fields, properties, like person. Both ways are fine. Person as a container might sound weird, but when you think about it, if let's say a robot can have such properties as name, surname, age, and height, then robot shouldn't be a person. Is a relation doesn't really make sense then, because if person also implies on being alive, then robot is not alive. So composition, which means having a class, a separate class for such a grouped, lumped, encapsulated properties, is also not a so bad thing. Primitive obsession is a funny code smell, because sometimes we repeat ourselves with primitives, primitizing everything. For example, phone number is not a good idea. Phone number has phone number first and foremost is not a number, it's a string, and in different countries it's written differently. Phone number is made of a country code, it's made of, I mean, it depends on country, so it has a country code, it has area code, and it has a certain format of how it's being displayed based on a country it's in. So phone number shouldn't be a string, phone number shouldn't be an int, phone number should be a class. A class which represents a very simple data structure for a phone number. Sometimes we also use properties to define what type an object is, and that's fine. But when those properties base behavior, like based on the properties we have behavior, picking behavior, we should extract them to different types as well. So how do we solve issue of primitive obsession? First, I'll show how not to solve it. So we have a class person. Male is person, female is person. And person has a gender, right? So if we split male and female out so that we no longer need a gender primitive, then we are in a bit of a trouble. It's inherently not visible, but we don't pick behavior based on it. Like in this case, we look at male and female classes and we can see clearly, I mean, we can understand that male is not a person, female is not a person. The relation between the classes is not just like that. And when we go and expand our domain with other entities which might also be male or female, we kind of fail at that, because I want a person to be a teacher. I don't want male or female to be having their own behavior, because I won't be able to reuse the behavior for a female teacher or for a male teacher. So it's a bit tricky. From this comes also the diamond problem. Then I will need to figure out how I want to inherit two classes, maybe, if I want female behavior and to also be a person, a teacher. I don't want to say that teacher is male only or female only. So since there is no behavior based on a property, we can simply put this back to a property and no type is needed. So that's not how we solve primitive abscission. Primitive abscission can be solved like this. If we have a person who has phone number and country code, we can do something with it. This is not clean because we have several fields which basically refer to the same thing, a phone. So on the left we have ungrouped fields. On the right we have too much freedom, because phone number, it won't be validated. So we can put anything and it will succeed, but it shouldn't, because it needs to be validated. Person will need to validate phone number. Person will need to validate all other person stuff, and we don't want that. Phone number should be validated when it's being created, not when person is created. So a solution to this is extracting phone number to a class. And like this, we have just those things that we had in the person, maybe some extra as extension for phone number, and the string method to format it into a format for a certain country. Maybe phone number in general will mean that it is an NA phone number, but we can inherit phone number class and make a European phone number class. Would I regex phone numbers? I think for a full validation, if it's a phone number, it makes sense. It makes sense. A phone number could have a dependency, like not a dependency, but a public method, maybe even a static method, which accepts a string and validates something if it's a phone number or not. It does make sense since there are many combinations. But yeah, it does make sense. But on the other hand, if you work with a specific region, you shouldn't treat all of those. Extension is, for example, for country code, for country where you use plus, for example, Lithuania uses plus 370. So 370 is an extension. And after that, you have just a phone number. Just a number which is both in the country, used in the country and outside the country. An extension is what you use internationally. Probably NA is +1 or something. I'm not sure about other countries' extensions. But yes, you could use regex for validating if it's a phone number in general. But if you know what region it is, I think a simple check would do. I mean, you said there are many layouts, combos. Yes, but if we are working with a specific region, we know exactly how it looks like. So it's easy to determine. we can tell that the extension string for extension should start with a plus, for example, and then it should not contain more than 3 symbols, for example. And that's good enough validation for extension. Number, well, it depends again on the country. In European country, it should contain only digits, so that's all the validation we need for number. And area code, it should be 2 symbols only. So that's all the validation we need for phone number. So regex is maybe a bit of an overkill here. Let's move on to another category. It's object orientation abusers. By the way, is the sound fine? Is there any bad sound? Okay, good. So this category basically means that there are smells which are a failure of object-oriented programming, but that doesn't mean that object-oriented programming is bad. It just means that it was misunderstood or ignored. So first category is switch statements. It basically means that there are many logical flows for your program. Like there is one if statement with many if-else statements, or there is big, long switch case statements with many cases. So how do we treat that? Well, basically we treat that with splitting behavior based on what is being switched. Well, when we use switch, we determine it based on a specific property, value of that property. So instead of determining value of a property, we can build behavior based on that value and then just execute the behavior that is being built based on the property value. This works especially well when property is a type. If it indicates a type, we can definitely make it a subtype of behavior. Just an object, a class object of behavior, and put an interface which represents the behavior. If we have a switch for a norm which has 100 values, so your switch will look for 100, so there will be 100 switch cases. And if each of those switch cases holds a behavior, then definitely the best way would be to put a type for each enum and remove enum altogether. Well, actually, removing enum is not needed. I mean, you can keep it, but you should have a type for it. So like that, then you won't need to have one long place where you define it, how each behavior should be done based on a case. You will have it in distributed places, and you can add or remove behavior. If the logic based on like which is based on a norm is just a very simple thing like returning another value or using another formula, then instead of behavior you can have a dictionary of things that are based on the enum value. So it could maybe return another thing or execute a little function, some other thing. Basically, if it's really simple, you could also consider a dictionary. And then you would just put enum, ask from that dictionary enum, and call whatever is at the value of that dictionary. It's usually nice when you have strings, for example, or other values, like when enum value refers to another value, then dictionary is really good. But in other cases, for behavior, you shouldn't have long switch statements and instead use types. And there is no other solution as far as I know. Also, if there is a chance that, you know, such case does not exist or that there was a null passed, then you should also introduce null object as an object which handles cases when it's being used, when the thing that when it's being used, when the thing that was needed to process was a null. So then you should simply have a subtype of null object which does something, but it won't throw a null reference exception. Temporary field basically means that you have, so it's a smell, which means that you have a field which is used in really few cases, rare cases, where value is set in a method which uses them. So basically most of the lifetime of a class, you won't be able to, I mean, you can use it whenever you want the field, but you don't use it for whatever reason. Only when you call the method, you set the field, and then when you're done, you reset it again to initial value or to null. That's a really bad thing to do because you ain't gonna need it. You don't really use it all the time, so why do you need it only then? Maybe you need it to transfer data, easier exchange field value from one method to another. But there's a better way. And a better way is splitting that to a class which uses that field and using a null check. Or another way is passing that field from the outside because maybe you don't really need it in the class itself. So here's an example. We have physical education teacher and 3 balls for 3 lessons. When we use a single lesson, we use a single ball. So when teacher gives a single lesson, he uses only 1 ball. Let's say he gets the ball somehow, but that's not the point. Design for this class is also flawed, of course, because getting ball should be externalized. So it should be like set volleyball instead of get volleyball, maybe. Anyways, volleyball is used only in give volleyball lesson, basketball only in give basketball lesson, and so on. That's not good. And we can fix this by externalizing the ball. We don't need ball in physical education teacher. We need the ball outside it. Teacher doesn't have balls. He gets them from the outside. So give volleyball lesson accepts volleyball. That's all. And temporary field, 3 of them in fact, are no longer used in the refactored version. Refused bequest is another code smell, which means that we have a request, not a request, but a class which basically fakes another class, which does what the other class does, but partially. It either does more than it and forms no logical relation, or it does take from the base class only a very little part of it. So in either case, it fakes it. It's incomplete abstraction. When we cannot say about classes that one class is another class, then inheritance should not be used. So in those cases, we should split the classes and convert inheritance into composition. Another code smell is quite silly one, is when we have classes with different interfaces for the same thing. So we have And this is a case usually for really old projects. So we have two classes for the same thing, and maybe both of those classes were done slightly different, and then we look at them both and we don't really know which one should we pick, which one should we keep. And we should be brave about it and simply delete the one class that we don't need. And that's the way to solve this issue. Last category that I will talk about today is change preventers. It means that when we change something, we will need to change other things too. And we want to change one thing when we want to change one thing. So, divergent code is a code smell, meaning that changing something inside a class requires a change across multiple methods. Like if you change one method, other methods need to be changed too, because for whatever reason they are related. And this means that class has more than one reason to change. And such change also means not only that changing one method changes like literally insides of the other methods, but it means that if we have changes for reading, we shouldn't even look at the place where writing was implemented, because that's a noise. We don't care about that. So splitting stuff out is the way to solve this code smell. Here we have two implementations for a file class. On the right side, we have file class that C# has: read text, write text, static method, static class, and we can read contents of file as text, and we can write text to a file. If reading and writing text is very small, simple, they can be in the same class. If they're not, they should be extracted. If they're more than a few hundred lines of code, they should definitely go into their own classes. On the left side, we have a different file where we basically say that a file has a name, extension, and path. This is more like a file info class, and like this, we read and write files. On the left, it's not a very clean solution, but we will see what we can do with it. So the problem, back to the problem. When we change writing, reading changes too, and that's not clean. It doesn't change, but it affects the class where reading is implemented, so we don't want that. What we can do is to split reading and writing into separate components and inject them. And now reading and writing will be implemented from the outside. The benefit of it is that we can mix readers and writers for specific file types and maybe subtype the file types. Let's say when we want to read JPEG, we will have an image file reader, but we will have a text file writer, maybe something like that. Let me go back a bit. So the key part here is to know that file itself basically acts as a proxy here. It does contain a minimum info, just name, extension, and path, but the behavior comes from the components that it got injected. File reader and file writer, both are abstractions. The implementations come from outside. Shotgun surgery is the opposite of what was it? Divergent code smell, because it involves multiple classes, and the cure for it is to having a single class for those many responsibilities. But a single class doesn't mean that everything should be implemented in one class. It simply means that it should be composed in one place and not in multiple places. If we use reading file and writing file, we should not use file reader and file writer separately. Maybe we can, but if we consistently use both things, we should group them into one. So here we have too many things split. We have mover, killer, healer, damager, all which affect a soldier. Soldier itself should be mover, killer, healer, and damager, not separate components controlling soldier. So imagine that God of War is like a service for simulating war, and it creates soldiers which do the simulation. Soldier is our domain entity. God of War is a service. So soldier, look at soldier class. It's really, really skinny. Doesn't do much. And soldier basically is a data class. Just a model which has no behavior. And it's not so good. What we can do though is move all the behavior in soldier class. Soldier should do those things by itself. Moving, healing, and damaging is responsibility of a soldier, not of God of War. And thus we have implementation shifted from God of War to soldier. We made low level contain all those things. So from high level, we should call low level and not the other way around. And that's what we just did with moving components, using those components from God of War to soldier. So this is how we treat shotgun surgery code smell. By moving many pieces, components, which are used together into one place, a composition of them. Parallel inheritance hierarchies is quite a rare code smell. And it basically means that there are two or more hierarchies, and a change in one hierarchy requires a change in other hierarchies. Change as in adding a new member to the tree of inheritance. And treating this is done through a visitor pattern, which looks like this. We have a vehicle, for example. The problem, we have a vehicle and types of vehicle like car and truck. And then we have a formatter for each vehicle, like car XML formatter, truck XML formatter. What if we have soap XML, soap formatter for a car, and then truck soap formatter? That's a problem. And this is taken from Stack Overflow, an example. So we have car vehicle, which accepts vehicle formatter. And we have truck vehicle, which accepts iVehicle formatter as well. And vehicle formatter works with each of the type. So the thing here to note is that in the previous scenario, we would need to implement, add a new class to the hierarchy tree, but here we don't add a new class to the hierarchy tree. We simply implement an interface for formatter, for different formatters. And it makes sense. If it's such a big difference formatting a truck and a car, then it's fine for them to treat formatting in their own place. So that's how it's done. Accept method basically calls visit of a formatter. If you want to know more about how and why this is chosen, I highly recommend reading the answer of Stack Overflow and looking at visitor pattern in detail. I don't really use it. It's quite a quite a rare case. Now, do you have any questions? And is there a smell that maybe you don't understand that you would like more clarification? Okay, next lesson. Well, I think this one is not clear. It's not clear for me that much as well. Oh, 2 people are watching, though it says only 1 is watching. Interesting. Okay. Thank you guys for watching, and I'll see you next time. So bye bye.